You'll have just a short little quiz on Wednesday covering just these two things. Real simple, nice little boost at the end of the quarter. Yes, Wednesday.
Wait, next Friday's last day of quarter.
Yes, next Friday's last day of quarter. Okay, so we're going to talk about radian measure very, very early in chapter 15, maybe chapter 14, I can't remember. We talked about how we have two different ways of measuring rotation, angle of rotation, as degrees or radians. Okay, degrees measures that into your angle. Okay, but the distance of the arc is the radian measure. So radian is more of kind of a measurement of length. An angle with its vertex at the center of a circle that intercepts an arc on the circle equal in length to the radius of the circle has a measure of 1 radian. Okay, so the measure of the rotation, this value right here, now let's do that in blue, this value right here, 1 radian, is relative to the radius of the circle. Okay, so there's not one specific length for a radian. I can't say that a radian is 1 centimeter or 3 inches or whatever. It's relative to the circle. So the larger a circle gets, the larger 1 radian becomes. Okay, so it's relative to the radius of any given circle. We can convert back and forth between degrees and radians with a very simple ratio. Okay. So real quick, before we get into that ratio, if I do a full circle, how many degrees is that? 360 degrees, okay? 360 degrees is 1 full rotation, all right? Anyone who took trig, can you tell me how far around a circle is in radians? Angie, do you remember? How far around a circle is in pi in it?
Right.
2 pi. 2 pi is the distance around the circle in radians. 2 pi radians. Okay? 2 pi radians. Radians. Where we get that 2 pi radians, actually, or the relationship to, as someone said it, the circumference of a circle. The circumference of a circle is 2 times pi times the radius. 2 times pi times the radius. That's the circumference of a circle. And so based on the radius, the circumference gets larger because radians get larger. Okay? So a full circle is 360 degrees and a full circle is 2 pi radians. And so we can write a ratio comparing those, either 360 over 2 pi or 2 pi over 360. That's a ratio comparing degrees to radians or radians to degrees. Well, when we simplify both of those fractions and we divide them by 2, we end up getting either 180 over pi or pi over 180. And those are our conversion metrics to go back and forth from radians to degrees or degrees to radians. Okay? And whichever one we use is going to be based on what unit do we want to end with. If I want to end in degrees, I want my degrees to be the top part of my ratio. If I want to end in radians, I want the pi, the radians, to be the top part of my ratio. And that's going to be which ratio we use to convert to whichever metric we want. So let's do some conversions. Okay? Degrees to radians. All right? So whenever I'm converting degrees to radians, I want to use the metric where radians is on top. So I'm going to take 45 degrees, and we're going to do a little bit of dimensional analysis, stoichiometry, unit conversion, whatever you want to call it, and we're going to multiply by our conversion factor. Okay? So whenever we're going from degrees to radians, we just want to multiply by pi over 180. Okay? Typically, when we are converting from degrees to radians, we are often going to leave an exact value in terms of pi. And so it gets really simple. There's not a lot of extra work that you have to do. We just want to simplify the fraction. Okay? So if we multiply this together, we just want to see if we can simplify our fraction. And I mean, your calculator will do that for you, so you really don't have to kind of do a whole bunch of work. Reduce 45 over 180 into 1 pi over 4, or just pi over 4. Reduce your fraction, leave it in terms of pi. Okay? Leave it in terms of pi. When it says leave it in terms of pi, write it in terms of pi. In terms of pi, that means we're going to leave pi as that Greek letter. We're not going to get an estimate value. We're not going to round it. Okay, so same thing with each of these. We just want to go ahead and multiply and multiply. Go ahead and take a minute and simplify both of those fractions. We only have b, negative 270 over 180. What was that simple? Say it again. Negative 3 pi over 2. We can just take negative 270, divide it by 180, and then math, enter, enter. Nice little conversion for us. Negative 3 over 2. All right? Anyone else see? Okay. So there's our converting to degrees to radians. When we're going from radians to degrees, we just flip that ratio. We want our 180 to be on the top. And the benefit of that is usually, not always, but usually, our radian measures have pi in them. If not, then we're going to have to do some estimating when we're rounding. So you have to pay attention to whether or not you need to round. But when I do 9 pi times 180 over 4 pi, the pi's will reduce and cancel out. And so we're left with 9 times 180 over 4. Which gives me what? $405. Okay. Times 180 divided by 4. Okay. B. Okay. Now for C, we're going to have to round because we're not given those pi's. So usually in a case like that, it's going to tell you to round to 1 decimal place. Let's do 2 decimal places. So we'll do 4.25 times 180, and then we'll have to divide it by pi. So what do we get at 2 decimal places? 0.51. And then all of those are in degrees on the right. Pi is right above the exponent symbol right here. All right. So conversion is pretty simple. You just need to remember the ratio of 180 to pi. Whatever measurement you want to end with, that should be at the top of your ratio. Multiply and simplify, round if necessary. Okay. So these are some popular degree measurements, the equivalent radians, and their approximations in radians. So these are things that show up a lot within the conversions. What's important to note is that the standard convention is, if it's in degrees, you have the degree symbol. If there's no degree symbol, it's assumed to be in radians. Okay? So if I just list and say that theta, the measure of an angle, is 30, just as that. That's assumed to be 30 radians. If you mean 30 degrees, it needs to have a degree symbol. Okay? And radians is normally written in terms of pi, but not always, as we saw here, 4.25. There's no degree symbol. There's no degree symbol here. And so we know it has to be in radians, even though it's not written in terms of pi. So that's the general convention. Okay? And so what we can do is now we can take our radian values and we can convert it into our degree measures and find the trig function values for each of these measures based off of our special right triangles. Yeah. Okay? So we want to find tangent of 2 pi over 3. We need to convert that into degrees. So 2 pi over 3. If I want it in degrees, what am I going to multiply it by? 180 over pi. So we have 180 over pi, which gives me what? So we've got tangent of 120 degrees, and now we can use our special right triangle to find tangent of 120 degrees. So how do we go about starting that? What do we need to do first? I know we did. Find the reference angle, okay, by subtracting from 180. So what quadrant is 120 in? Quadrant 2. Okay. So over here, what is our reference angle? 60. All right. So side opposite is going to be what? Side adjacent is going to be what? And hypotenuse. 2. Okay. So what is tangent of 2 pi over 3 going to be then? Say what? What side do we? Yeah, negative root 3. So it's root 3 over negative 1, which is negative root 3. Okay? All right, sine. Let's convert 3 pi over 2 into a degrees. Okay? So where is 270 located? It's down here, right? The quadrantal angle is on the axis. Okay? So we'll need to kind of use our x and y and our r in order to find our sine value, right? So we can pick a point on this line. What's any point on this line? I need the whole ordered pair. Is it 0 or 0, negative 1?
0.
0, negative 1. So we've got x and y. What's our radius, if that's our point? 1. Okay, so what ratio do we use for sine? R is our hypotenuse.
Y over R.
Y over R. So sine of 270 y over r, which is negative 1. Okay? Negative 4 pi over 3. What does that angle measure? Degrees. What's that angle in standard position? 120. Okay, so we're back in quadrant 2 again. All right, and so now we need cosine, so we can just use this triangle again. What's cosine going to be? Okay, same triangle. Okay, is that it?
Yep.
Boom, see, told you, quick and easy.